Today we are going to be talking about simplifying rational expressions. And first we kind of need to talk about what a rational expression is. And so I have a list of examples and non-examples here. And just looking at these, I want to highlight a few differences. If we notice in the bottom of each of our examples, each one of them has variables. And if we notice in the bottom of our non-examples, all of them just have numbers. There's no letters at all. And so kind of that's a huge difference, is that we have variables in one on the bottom in the denominator. So I want to put that variables in the denominator as a noticeable feature. Which is the bottom. We also have some in the top, but we don't have to have some in the top. And then something else that I notice, and we will talk about, is that they are factorable. Factorable expressions. In denominator and numerator, which is the top. So we have stuff that we can factor in the bottom, and we have stuff we can factor in the top. So our steps for simplifying a rational expression, excuse me, our steps for simplifying a rational expression, first off, is to factor everything. Factor everything, whether it's by GCF or into binomials. Lost track of my letters. There we go. So either factoring by GCF or binomials or both. We are going to be factoring everything if possible. And then we are going to cancel out factors, not terms. So we're going to be factoring out groups of things, or canceling out groups of things. And we are going to check that our answer is fully factored and simplified. Okay. So we're going to start small with some simple expressions. What we are going to be doing is we are going to simplify or divide our fractions, and by reducing any numbers that we have and crossing out any like terms. So looking at our first example, I'm going to break it into two pieces. I'm going to look at the numbers separately and then the variables separately. So I have 60 over 12. And then we have x to the power of 3, which is the same thing as saying x times x times x. And then on the bottom, we have x squared, which is like x times x. Now with the x's, if I see something that exists in both the top and bottom, I am going to cancel them out. So for every x on the top that I see and on the bottom, I'm going to cancel those out. So I have one set canceled, two sets canceled, and then I have an x on top by itself. That's going to stay on top. That's not getting canceled out. And then if we look at 60 over 12, you can do this using your calculator or using mental math. We are going to simplify this fraction. We want to reduce the numbers as much as possible. In your calculator, you can do alpha y equals to get a fraction created and then put 60 over 12 in it and hit enter, and it'll reduce the fraction for you. Or you can do 60 divided by 12 and then math enter to turn it into a fraction. I know these are both divisible by 12. And so when I divide these both by 12, I get 5 over 1. And so both of those numbers are going to go with me as well. So I have 5 on top. I also have an x on top over 1. Now, dividing by 1 or having a fraction with 1 in the bottom does not change anything, so I can actually simplify this just a little bit further and just say 5x. So that is our final answer for A, 5x. Looking at example B, one thing I want to note is if we see addition or subtraction, put parentheses around it. So I'm going to put parentheses around this entire expression that has addition or subtraction. Those are locked in together. I cannot break those apart. I repeat, I cannot say, oh, 3x and 3x, boom, boom. Those do not cancel out. The 3x on the bottom or in the denominator is locked in with that subtraction with the 1. So those are one unit together, one set of cancelable terms. So they have to kind of go together. Wherever the 3x goes, the negative 1 goes. And so we cannot cancel it out. So this is the final answer. There is no factoring. There's nothing to factor or cancel. That is the final answer.